Hello everybody, this is Mr. Bowman. Today we're going to be looking at standard form, specifically how to turn something into standard form and what exactly that means. So, what does it mean to be in standard form? So standard form looks like ax plus by equals c. Okay, it's usually how we see it written. So x and y are the normal variables. So notice that they are on the left side. So all the variables are on the left side, and our constant, the thing with no variables, is on the right. Okay. So that is important to notice because that's going to be one of the first things we have to do. We have to make sure it is in order. Okay. Then these a, b, and c's are coefficients or constant, as the case may be, have some rules of their own. So, number one, a, b, and c have to be integers. Okay, so what does that mean? That means that a, b, and c, none of them are allowed to be fractions or decimals, right? We're allowed to have positive and negative whole numbers. So no fractions or decimals anywhere in here. Okay. Other important rules. Sorry, I lost my train of thought for a second. A has to be positive. Okay, so B and C, if there's some negative signs, that's okay, but A has to be positive. Otherwise, theoretically, we might end up with two instances of the same thing in standard form, and we want a single option. So we do need A to be positive when we're in standard form. All right, and one other one, just to throw it in here, just so it looks like this, but there's some wiggle room on this one, to be honest. A and B are not allowed or cannot be 0. Okay. If you do, you're going to lose a variable. Theoretically, you can still have lines. That's how we get our horizontal and vertical lines when they're 0. But that's going to be the only time that happens. So normally A and B are not going to be 0, and I know sometimes they get sticky about that. So this one is kind of a sometimes rule depending on where you're working. So, but these first two are always the case. A, B, and C have to be integers, and A specifically has to be a positive integer. So that's going to be important here because that's how we're going to make sure we're in the right setup. Okay. All right, so what does that mean for us? Well, one of the ways that we see this most often is turn something into standard form. So if we were to try to do that, let's say we had something like, let's start with an equation first. We have y equals 1/2 x plus 4, something like that. And we want to turn it in standard form. Well, first off, let's go ahead and get rid of these parentheses. So we'll distribute that in here. Okay. Then I need to start following my rules. So, and you can do a lot of these in whatever order you want. I could get rid of this fraction. I could move the x. I like to get them in order first because that's one that a lot of people mess up. They'll either put the y before the x, or they'll leave a variable on either side or something like that. So I'm going to subtract my 1/2 x to both sides so I can have my x's, then y in constant. Then I just have to worry about the coefficients, and I don't have to worry about moving things anymore. So now that I have that, let's go through. Are they all integers? No, they're not. We have a fraction. So to get rid of a fraction, I need to multiply everything by the denominator of that fraction, which in this case is 2, which leaves me with negative x, or negative 1x, plus 2y equals 4. So make sure you do distribute that to the y as well. So now I have integers, negative 1, 2, and 4, so those are good. A has to be positive. Shucks. Okay, so I need to multiply everything by negative 1 to make it positive, or divide by negative 1, however you want to think about it. Get the same thing. Okay, so now A, B, and C are all integers. In this case, positive 1, negative 2, and negative 4. A is positive 1, so that works. And if we go with our kind of questionable third one, I don't have any zeros, so I'm good. So this would be standard form. Okay, so if you start with an equation, it's just moving things around. If you get one of our other cases where we have things like, say, a point and a slope, if our slope is 1/2, or use 1/2, that's okay, and I have a point at 3, 5, I can do this, I just need to find an equation first, okay? So let's use our point slope form, so y minus y1 equals m times x minus x1, and start plugging things in, and then I can have something like this to work with. So let's see, I'm going to plug in for x1, y1, and m. So the y coordinate is 5, my m is 1/2, my x coordinate was 3. And then it's going to work out pretty similarly to this one after we do that first kind of step there. So I'll distribute y minus 5, I'm not going to do anything with, but I have 1/2 x minus 3/2. Then I need to move things around, so I'm going to do two things here. I'm going to add 5, and I'm also going to subtract my 1/2 x. So, okay. And this is gone, so I just have the negative 3/2 plus 5, which is 10/2, so I have 7/2 over here. Notice I have two fractions now. If they have the same denominator, it doesn't change anything. I'm just going to multiply everything by 2 still. If they were different, you just need to find a common denominator and multiply by that. Okay. So right now there's still 2. And I'm not going to do this right now, but you can notice, if you notice this is a negative, you can flip this and do a single multiplication as opposed to splitting it like this. I like to, when we're going through it at the beginning here, do each of my kind of categories or constraints one at a time. So I don't do that, but after you get more practice, you may choose to do that. Okay. So then I need to get rid of that negative by multiplying by -1. Okay. And that's my standard form. 1x minus 2y equals -7. So a lot of these follow that same kind of pattern, so jump in, try it out, and just make sure you're following your rules.